Hi, my name is Lauryn Avery, and I'm going to discuss my research, which was on the effects of glyphosate on chicken embryo development. So glyphosate, which is the main ingredient in Roundup, is becoming a problem to our ecosystem because it is widely used in different agricultural practices, which is problematic to us because we are being exposed to glyphosate since Roundup is widely used. There have been studies that tested high doses of glyphosate in chicks in Xenopus, which resulted in birth defects and poor overall development. I tested chick embryos to physiologically relevant concentrations of glyphosate to examine its effect on overall embryonic development. And the EPA reference safe dose for glyphosate is 2 milligrams per kilogram per day. And I chose to use chick embryos in which to study development because they develop similarly to humans and share many of the same genes and developmental pathways. I started my research by first preparing 3 different concentrations of glyphosate to give final concentrations of 25, 2.5, and 0.25 milligrams per kilogram. Next, I injected multiple rounds of eggs with the prepared glyphosate concentrations and PBS, which the PBS was used as the control and as the diluent. Then I examined the eggs at 3 and 7 days of development for their overall weight, heartbeat, and developmental stage. I also took tissue samples from all of the surviving embryos for DNA and RNA extraction for later analysis of any epigenetic changes. In the first picture, you see a 3-day embryo. In the middle picture, you see a 7-day uninjected embryo. In the last picture, it also shows a 7-day embryo, but it is injected with the highest glyphosate dose, which was the 25 milligrams per kilogram. So my results are as follows. In this graph, you can see that high glyphosate concentrations resulted in lower embryo survival compared to the diluent shown in yellow. And you also see that with this graph, where embryos injected with high glyphosate concentrations weighed less than the diluent, which is also shown in yellow. And in this third graph, it also shows the embryos were behind development, meaning the embryos injected with the higher glyphosate concentrations had slower development than embryos injected with PBS, which those embryos are shown in yellow, and the embryos slower in development are shown in purple on this graph. In this last graph, you can see that glyphosate didn't have much effect on embryo heart rate, as embryos injected with any of the glyphosate concentrations had typically the same heart rate as the embryos injected with the control, which is the PBS. I performed Fisher's exact test of independence by comparing the 2.5 and the 0.25 glyphosate concentrations to the diluent, but the results were not significant. And I was unable to do statistics with the 25 milligram per kilogram concentration because the sample size for that concentration was too small, but I hope to increase my sample size as I carry out my research. Overall, the trend towards reduced embryonic viability and slower overall development implies that glyphosate could have adverse effects on human development. I am currently analyzing the extracted DNA for changes in methylation levels and performing semi-quantitative RT PCR to look for changes in RNA expression levels for key retinoic acid signaling genes. And I'm looking at the retinoic acid signaling genes because glyphosate has been shown to affect the retinoic acid in xenopus. And I want to see if glyphosate affects the retinoic acid signaling genes in chick embryos. Thank you for listening to my research presentation.